Here we have a problem, an applied problem involving an exponential function. The grasshopper plague is spreading at this rate, where n is the number of weeks after the initial observation. So A, find the original affected area. Original means n is equal to 0. So we're calculating A of 0. 1.15 to the power of 0 is 1, so it's just going to be equal to 1,000 hectares. B, find the area affected at these different times, so that's going to be A5. That's 1,000 times 1.15 to the power of 5. And we get an answer of 2,011.36 hectares. And point 2, after 10 weeks, that's going to be A10. So that is 1,000 times 1.15 to the power of 10, which is 4,045.56 hectares. C. Sketch the graph of the affected area over time. Now we could probably do this without the calculator. We do have access to the calculator for this question, so we could use that as well. But let's try doing this without a calculator. First of all, we need to know that it starts at n is equal to 0. Our asymptote is going to be 0 because the plus c is 0, but our y-intercept is 1,000. So it's coming through at about 1,000, or at exactly 1,000 even. So the graph looks something like, on this side, it's got the asymptote, and then it comes up, and then it's doing something like that. So on this side of the y-axis, when x is positive, we need to draw the graph. Okay, if I get rid of that bit there, maybe it's coming through something a little bit like that slowly to start with, and then steeper and steeper and steeper. But it is going down to an asymptote at y equals 0, sorry, on the left-hand side of the y-axis. We're going to label this properly. This is A, and this is N. Part D, use your graph to find how long it will take to reach 8,000 hectares. So for this, we're looking for that point there, where that is 8,000, we're looking for the point of intersection. This point, we're definitely going to want to do this on our calculator. So we're going to draw the graph of 1,000 times 1.15 to the power of x. And the second graph we're going to draw is 8,000. And then we're going to draw the graph and change our view window to be able to see the graph that we want to see. When we plot that in and we change our axes to look something like this, we get the coordinates of this point here being 14.878 8,000, which means it's going to take 14.878 weeks, or 14.9 weeks, or 15 weeks to the nearest whole week. E, comment on the validity of this model. This model is going to be valid for a period of time, but eventually it's going to become unsustainable and invalid, because this is just going to keep getting bigger and bigger and bigger. And that's just not realistic, because at some point the population of grasshoppers is going to stop increasing. It cannot increase infinitely forever.